Good day, everyone. Welcome to our session. Today we are going to continue our discussion on the trigonometric substitution. So these are the integrals that involve square roots, such as this. Okay, where from this square roots, and this a is a constant and can be solved using the trigonometric substitutions. These substitutions are as follows. We have x equal to a sine theta for the integrals with square root of a squared minus x squared, and x equal to tangent theta for integrals with square root of a squared plus x squared, and x equal to a secant theta for integrals with square root of x squared minus a squared. Okay, so you don't have to just memorize them. What is important here is you understand them. Okay, so I'll give you the technique on how to do this, or how to solve problems that involves square roots or radicals, specifically square roots, using trigonometric substitutions. Okay, so do you have any questions so far? So the technique here, class, is by the way, this idea works for this if our integrals contains this or involves this square roots. Then after that, we need to use the trigonometric identities. Okay, trigonometric identities: 1 plus tangent squared theta equal to secant squared theta, or 1 minus sine squared theta equal to cosine squared theta. Okay, so the technique here is that we need to put them into, or put sides into relationship, such that we get x over a for tangent or sine or secant. For example, if we take this scenario, class, if we have this square root of a squared minus x squared. So the first one, this. Okay? So we can say that this involves, or this is just part of the Pythagorean theorem, right? Where I can draw a triangle, specifically a right triangle. Okay? And then from this given, from this given, next thing to do is to figure out whether this is hypotenuse of this triangle, or this is a side of this triangle, or a leg, one of the legs of this right triangle. So since this is minus, so we can say that this is just one of the sides, or one of the legs of this triangle. Okay? And then we have to figure out also which of this a and x would be a hypotenuse, or one of the legs of this right triangle. Okay, so since we have this minus, so it can be that x is the hypotenuse or a is the hypotenuse. Now, for example, if we suppose that x is the hypotenuse, so we know that hypotenuse is the longest side. So we have this shorter side, longest side. Then when you subtract the short by the longest side, then we have a square root of a negative. So this can't be that x is the hypotenuse. So we can say that a is the hypotenuse. So let us label our triangle. So this is our a. Okay. Now, okay, I'll put my angle here, theta. So now the question is, which of these legs, or which of this side should be for x? This side or this side? So take note that our goal here is to get this x over a, x over a for tangent and or sine or secant. Okay, so these are the trigonometric functions that will give us a simpler expression for x. Okay, so for example, if we use say sine, no? Sine, I'll suppose that sine. So sine is opposite over hypotenuse, right? So if we consider this side as our x, so we can solve for sine. If we consider this for tangent, so tangent opposite over adjacent. Okay, so we don't know yet what is this side. Now let's figure out that, or let's suppose that x is in this side. So if this is our x, then from our identities we have, or from our definition, we have sine of this angle theta is equal to opposite over hypotenuse. Right? From our code, remember from our code we have su katua. So remember, we have this su ka tua. Still remember this? So for sine, we have sine, su, mean opposite over hypotenuse. So from this triangle, we have opposite of this angle, sine theta, opposite, which is x, over hypotenuse. So from here, we can solve for our x. Right? We can solve x here, where x is equal to a times sine theta. Alright, so this is the value for x that we are going to substitute in our function that contains this. Okay, so next, for the second one, okay, so for the second one, we have this one. This. We have square root of a squared plus x squared. Okay, so again, we're going to use our reference triangle. Okay, so assuming this is our right triangle. So now the question is this a side or a hypotenuse? So if you're given this, oh, by the way, we forgot, no? Here in our first triangle, so this is a, this is x, so therefore this side here is square root of a squared minus x squared. Okay, so to continue with the second part, so our second part is we're given square root of a squared plus x squared. So is this a side or is this hypotenuse? So since this is plus, so it means that this is the hypotenuse side, because from Pythagorean theorem we have this hypotenuse side, okay, or the square, the hypotenuse side is equal to the sum of the squares of the two sides or two legs. Okay, so in other words, this is a squared, the square of the side a squared equal to e squared, this is square root of e squared plus x squared. So meaning this is our, either of these two would be x or a. It can be your a here and this is your x, or it can be your a here and this is your x. Okay, so since this is the hypotenuse, all right, so this is our e squared plus x squared. Now the question is, which of this side would be our x and would be our a? Now take note that our goal here is to express our, to get x over a. Okay, so the position of x and a should be in such a way that we get this x over a for tangent, sine, or secant. So again, this is our angle theta. Now, for assuming that I will use a here, a. So if this is a, then this is x. That will give us this for the hypotenuse. Or if this is our a and this is x, that will also give us this length of this hypotenuse. Now, our goal is to produce this x over a for any of this. So for example, if we put x here, okay, so if we put x here on this side, then we can have our a in this side. So if we consider, say for example, tangent, we've done already with sine, then let's try for another one. Say, if we try secant, when we speak of secant, that is hypotenuse over adjacent, so it's not appropriate. If we use sine, then sine of theta is opposite over hypotenuse. So again, it's not good because it involves radical. So it should produce x over a. So there's no other way to get this x over a except for tangent, no? Tangent of this angle, because from our definition, tangent of the angle is opposite over adjacent. So tangent of theta is equal to opposite, which is equal to x. Okay, opposite side over adjacent, which is equal to a. So from here, we can solve for our x, where our x is equal to a times tangent theta. Right? X equal to a times tangent theta. Alright, so that is our second scenario. Now, the third one. So this is our third one. Okay, this square root of x squared minus a squared. Square root of x squared minus a squared. So again, let's draw our reference triangle. So assuming this is our right triangle, and this is our angle theta here. So now the question is it a side or a hypotenuse? So this is a side. Is it a side or a hypotenuse? A leg or this hypotenuse? Sorry, it cannot be seen, so I'll draw this. I will redraw this in another cardboard. Okay, so I'll redraw number 3. So number 3, we have square root of x squared minus a squared. So again, I'm going to redraw the right triangle. So this is our angle theta. Okay, so the question now is this represent a hypotenuse or represent a side? So as you can see from this sign class between x and a, so this is negative. So negative, if it's negative class, that indicates it's a side. Okay? So it's a side. For positive, no, like the one that we had in the second one, this one here. So this is positive. So it means this represents the hypotenuse. Okay? So now the question is, if this is a side, if this is this represents the side, so which side do you think is this? And which of this could be the hypotenuse, this x or this a. Supposing we put a here as our hypotenuse. So we know that hypotenuse is the longest side of the triangle. In this case, in a right triangle. So if you put a here, so what will happen is that you have x minus a, and we know that a is the longest side. If you put a here, then this is the shorter side. So it means that shorter minus longest. So what will happen? We will get the square root of negative, right? Because this is smaller number, this is a bigger number. So definitely the difference would be a negative. So it cannot be. So therefore, we can say that this is our hypotenuse, x. X is the hypotenuse. Okay, so now our goal is to produce x over a. Right? As mentioned before, we need to produce this x over a for convenience, no? For easy evaluation of our integral. So we need to produce this one. Okay? So we've done already sine, we've done already tangent. Let's try, no? Let's try if we can use secant. So if we try to find secant, or if we say tangent, we know that x is already here. So when we speak of tangent, so we cannot use tangent anymore because it's no longer x on this side, right? If we use sine, again, we make use of this side. And this is not x anymore because x is already here. So we cannot use tangent, we cannot use sine, so the only one left is the secant. So secant, when we speak of secant, from our definition, we have so, ka, tua. And the co-function is ko, cha, kau. Okay? So what does it mean? This is cosine. So its co-function is secant. So therefore, for sine is adjacent over hypotenuse, its co-function is hypotenuse over adjacent. So therefore, this is this x, which is the hypotenuse. Then this adjacent should be our a. Alright? So this should be our a. So therefore, if this is a, this is our x, this is our a, then what this side should be? So this side should be the square root of x squared minus a squared. Okay? So from our definition of secant, so secant of the angle theta is equal to hypotenuse, which is x, over adjacent, which is a. So therefore, from here, we can solve for our x. Cross multiply a, so we have x is equal to a times secant theta. Okay? So this is it. That is the derivation of these different values for x for different scenarios, class. Okay? So remember that for the given x, okay, so I'll summarize it here. We have our first x, we have a sine theta, and the other x is a tangent theta, and there our third x equal to a times secant theta. Okay? So these are this is where you can get, so you have x equal to this one, then you can change dx, no, from dx to d theta, no, from here. So you take the derivative of this, so you can solve, you can express dx in terms of d theta, no, for this, and so with this one. So you have dx and express this in terms of d theta, so that you can do the needed trigonometric substitution. Okay? So, any question? So, I hope you were able to understand, class, how and why they looks like this and why we need to understand them. Not just memorize them. Okay, so I hope it can help. And in our next video, I'll show you another example in application of this concept. Okay, thank you very much. Bye for now.